So in the previous video, we introduced the concept of solubility of ionic compounds and the solubility guidelines table here. And I told you that not all ionic compounds are soluble, so you need this table to tell you which ones are. And it's really easy to read the table, so you just need to print it out and have it with you so you understand how to use it. I must warn you though, OWL, when you're doing the homework, sometimes it gives you a different table and they may give you some solubilities that I haven't mentioned. It's okay, just do whatever OWL wants you to do, but for your test, this is the table you're going to use, the one from your Stoker textbook, okay? All right, so we said that group 1A, always soluble. Anything that has an ammonium in it, always soluble. We said the acetates are soluble, the nitrates are soluble. Anything that has a chloride, a bromide, an iodide, you know, those halogens, they're all soluble unless they're hooked up to a silver ion, a lead ion, or a mercury ion. Okay, so those are the exceptions that make them insoluble. And then the last in this category of the soluble compounds are the sulfates. So the rule says that all sulfates are soluble unless they're hooked up to a calcium, strontium, barium, or lead-2. Okay, so what that means is that if you have, let's say, a zinc sulfate, or you have a potassium sulfate, or you have a silver sulfate, or you have a barium sulfate. You take a look. According to this rule, all sulfates are soluble. Great. But the exceptions are calcium, strontium, barium, and lead. And out of these, there's a barium. This is not soluble. This is soluble, this is soluble, this is soluble. Why? Because of the sulfate rule. All right. Now let's focus on the insoluble ionic compounds. And these are the ones that have carbonates, anything that has a carbonate, a phosphate, a sulfide, or a hydroxide. Okay, so these ions are the red flag for insoluble. However, there are exceptions. For the carbonates, they're all going to be insoluble unless they're hooked up to group 1A or ammonium, which makes sense because over here we just said that group 1A and ammonium cations are going to be soluble no matter what. So even though all carbonates are insoluble, if you have a group 1A or an ammonium, they're going to make them soluble. Phosphates, all insoluble, but what's the exception? Group 1A and ammonium also. Sulfides, all insoluble, but this exception is group 1A, group 2A, and ammonium. They make them soluble. And then the hydroxides, all insoluble unless you're hooked up to group 1A, calcium, strontium, and barium. Those are the heavy group 2A. We get into hydroxides in more detail later on in the semester when we're talking about the acid-base chapter, because this will determine the strong bases. Those are the soluble hydroxides. We'll get into that. So what I'm going to do now is I'm going to put a few molecules on this whiteboard, and it's just going to be practice so that you feel comfortable with these solubility guidelines, because I think this is really cool stuff. So let's say I have this thing here. Or I have this. Or I have this. Yeah, no, let's not do that. Or I have this. A couple more. All right, so I have 5 ionic compounds. I have calcium phosphate, zinc sulfide, ammonium nitrate, lead-2 chloride, and lithium carbonate. And I ask you, all right, which ones are soluble and which are insoluble? You just look at this chart. You look and see this phosphate here. It says phosphates are all insoluble unless they're hooked up to group 1A and ammonium. Well, this phosphate is not hooked up to a group 1A or an ammonium. It's hooked up to a calcium. So there, it isn't an exception. So this is insoluble. I'll just put an I for insoluble. Okay, zinc sulfide. Let's see what the rule is with the sulfides. They're all insoluble unless they're hooked up to group 1A, group 2A, or ammonium. Is zinc a group 1A? No. Is it a group 2A? No. Is it an ammonium? No. So this is insoluble. No exceptions. Ammonium nitrate. Well, both of these are in the upper area here that says ammoniums are all soluble. Nitrates are all soluble, so absolutely this is soluble. Okay, let's take a look at this one. Let's look at the chlorides. Do we have a rule for the chlorides? Yes, all chlorides are soluble unless they're hooked up to lead-2. See this exception here? So even though chlorides are soluble, but if they're hooked up to silver, lead, or mercury, they're insoluble. So this is insoluble. And then finally, let's look at this one. Carbonates, according to this, are always insoluble, but if they're hooked up to a group 1A, lithium is a group 1A, so it is soluble. So the lithium makes an exception to this rule. So even though carbonates are always soluble, or sorry, always insoluble, lithium is group 1A, so it makes it soluble. Lead is an exception to the chloride rule. Chlorides are usually soluble, but lead makes this insoluble. Okay, the only way to get really good at this is to just practice it, and once you practice it, you'll be awesome with the solubility guidelines. Just be able to use the table, and there are no tricks to it. Okay, good. The next video, we're going to start talking about calculations, where we're going to actually measure the concentration of solutions. So we're going to talk about concentration units. Concentration units. Because if you have two beakers and they both have sodium chloride in them, this is sodium chloride aqueous and this is sodium chloride aqueous, and I tell you, how do you know which one is more concentrated? You're not allowed to add anything to it. You're not allowed to weigh it. You're not allowed to taste it and tell me, oh, one is saltier than the other. How are you supposed to know? And they both look exactly the same. The only way you could know is if someone had labeled it. And in chemistry, we can never have a bottle unless we label what it is and the concentration. So the concentration units we're going to be talking about are percent and molarity. There are three types of percent: percent by mass, percent by volume, percent mass by volume, and then we'll do molarity. So the next video, we'll talk about the concentration units. We'll talk about how to calculate those units and how to use them in calculations. Okay?